Hi folks, this is Miss Hagen. Today I'll be looking at the optional extra practice for the quiz you're going to be taking. So the purpose is not to burden you with more work. The purpose is to give you more practice before you take the quiz. So I think this will be helpful for almost all of you, but it's not required to be in your binder for a grade. So the first part, I give you a table with different substances, so table salt, castor beans, some mushrooms, and some arsenic. I give you the lethal dose, the description, and a little bit about how the body reacts, just to give you some interesting information. The first question says, which substance is the most toxic? Okay, so the most toxic, the best poison, is the one that you have to give someone the least of in order to kill them. So in that case, that would be the castor beans. If you look at the lethal doses, okay, castor beans is the smallest, means per weight of your body you need a tiny, tiny amount of toxin to kill you. So it's the most toxic. Which substance is the least toxic? Well, it's the one you need the most of in order to get a response, and that would be table salt. Which makes sense because, well, I eat salt all the time and I'm still alive, so it doesn't make sense that a small amount would kill me. Okay. Number three, how many milligrams of ricin would be a lethal dose for a 70-pound child? So there's going to be three fractions you need to set up here. You start off with the 70 pounds over 1. Okay. The only place we can go from pounds is to kilograms. So up at the top, I give you the relationship. And then the last one, you need to get to milligrams. You're currently at kilograms, so you need to use the lethal dose. So for castor beans, 0.03 milligrams of ricin per kilogram of body weight. All my units cancel except for the milligrams, which is what I want my answer to be in. So you are ready to get out your calculator. You want to multiply straight across. So you do 70 times 1 times 0.03 divided by 1 times 2.2 times 1. Okay? The next question is set up very, very similar. So you start with the weight of the person and put it over 1. There's only one place you can go from weight. Okay? This time, though, we're talking about arsenic, not castor beans and ricin. So you need to use the lethal dose for arsenic. Okay? So your number for this question should be bigger than your number from the previous question because it takes more arsenic to reach the lethal dose than it does of ricin. The last one I'll let you try on your own. So the first two fractions are going to be exactly the same. This time, though, we're talking about sodium chloride. So instead of this 15 or this 0.03, you'll use the lethal dose for sodium chloride. But I'll let you try that on your own. The back gets a little trickier. So these next problems are going to start off the exact same way. So you're still going to start off the person's weight, put it over 1. There's only one place you can go from pounds. This is ricin we're talking about, so you need to use the lethal dose for ricin. And this last piece is the piece that's different. There are 2 milligrams. That cancels out my milligrams. In every 1 bean. This will give me my answer in beans. Okay, so once again, you multiply straight across to get your answer, and you should get somewhere between 1 and 2 beans if you did it right. Okay, the next one will be set up exact same. So you'll do 120 pounds over 1 times 1 kilogram over 2.2 pounds times, okay, then you want to use the lethal dose for the mushrooms times this fraction, 200 milligrams over 1 kilogram. And last, okay, you'll do times in 1 mushroom on the top divided by 2,000 milligrams on the bottom. Okay, so 7 and 8 are very similar. So for mass mole conversions, I'll do 1 and 2 for you and leave you to try 3 and 4 on your own. So we're told 34.1 grams of uranium, and we're asked how many moles. So this is an orange problem. Okay, the grams we're given in the problem goes first. Right here, you'll look up the molar mass for uranium. So you need to get out your periodic table and look that up. I'm just guessing here. Maybe it's about 238. So you want to look that up and fill that in. You'll multiply straight across, top and bottom, to get your answer. Number 2 is the yellow problem. So I'll set up the frame. So in the problem, we're given 0.5 mole. And then you need to go look up the molar mass for potassium chloride. So I think potassium weighs about 39 and chlorine 35. Add those up, put that here, and you should be able to get your answer. So number 3 is very similar to number 1, and number 4 is very similar to number 2. If you still have problems, come see me in class.